So today we are going to talk about how to recognize what theorems need to be applied in word problems. And before we begin, I want to make sure we review all 4 theorems that we have talked about this semester. Now, the first theorem has been a while since we've talked about it, but it's the intermediate value theorem. And the intermediate value theorem states if f of x is continuous over this closed interval of a, b, and f of a is less than y, which is f of b, or vice versa, f of b is less than y than f of a, then there's at least one value of c within this interval that equals that y value. Okay? The extreme value theorem states if f of x is continuous on this closed interval ab, then there must be an absolute max and an absolute min on the closed interval ab. These absolute extrema can occur at the endpoints of a and b, or at any critical value of AB. All right, the third one we talked about was Rolle's theorem. And Rolle's theorem states if f of x is continuous on the closed interval AB and differentiable on AB, and f of a equals f of b, then there's a guaranteed value of c on AB such that the first derivative is equal to 0. The mean value theorem states that if f of x is continuous on the closed interval AB, and differentiable on AB, then there's a guaranteed C value that exists such that the first derivative, which is the instantaneous rate of change, equals the average rate of change. So what we're going to focus on is really identifying the trigger words in word problems that symbolize what theorem we're going to use to solve. So let's look at this first word problem together. So, the rate at which water flows out of a pipe in gallons per hour is given by a differentiable function r of time t. The table below shows the rate as measured every 3 hours for a 24-hour period. The first question is estimate the value of the first derivative of 5 using correct units of measure. Explain what this value means about r of t. All right, well, we know that here, because they're giving us a table, we're going to have to use the average rate of change. So the first derivative of 5 is going to equal r of 6 minus r of 3 all over 6 minus 3. And we get 10.8 minus 10.4 all over 3. So 0.4 divided by 3, which gives us 0.133 gallons per hour squared. So what does this tell us about r of t? And this should be right away signaling to you, okay, what does the first derivative tell us? Well, since the first derivative is positive, that means the rate of flow is increasing at t equals 5. So once again, because the first derivative is positive, our original function is increasing. All right, using correct units of measure, find the average rate of change. Okay, so we're being asked to find a rock, which we should remember is the slope of the secant, which is equal to r of 18 minus r of 3 all over 18 minus 3. So 10.7 minus 10.4 all over 15. So 0.3 over 15 is equal to 0.02 gallons per hour squared. Okay, simple enough. So, is there some time t between 0 and 24 such that the first derivative is equal to 0? This right away should symbolize to you Rolle's theorem. Okay? this should symbolize Rolle's theorem to you. So we need to remember what are the 3 conditions of Rolle's theorem. So condition 1 is it continuous? And we can say it's continuous. We don't know otherwise. The water is continuously flowing. Step 2 is it differentiable? Okay, so we can say yes, it's differentiable. So then the 3rd condition of Rolle's theorem, if we remember, is that are there 2 values, all right, in which f of a is equal to f of b in order to make the first derivative equal to 0. So if we're looking, are there any 2 values within the 0 to 24 range, all right, in which the values are the same? And what you notice is at time 0 and at time 24, we do have that. So you can say r of 0 equals r of 24, and they both equal 9.6. So you can say Rolle's theorem guarantees a value of t on 0 to 24 such that the first derivative is equal to 0 because r of t is continuous on 0 to 24, differentiable on 0 to 24, and r of o equals r of 24, which equals 9.6. Okay, so let's look at another word problem together. The total order and transportation cost measured in dollars of bottles of Pepsi Cola is approximated by the function given, where X is the order size and number of bottles of Pepsi Cola in hundreds. Question A asks, is there a guaranteed value of R on the interval 0 to 3 such that the average rate of change is equal to the first derivative? So right there, you should have seen, they said average rate of change, and it's equal to the first derivative. So right away, you should think that is MBT. So we have to find whether there is a value. So remember what the conditions of MBT are. Is it continuous? All right. And is it differentiable on the interval 0 to 3? Well, since C of X is undefined at R equals 0, then C of X is not continuous on the interval 0, 3. Therefore, MBT does not guarantee a value. Such that the first derivative is equal to the average rate of change. Does not guarantee it. Okay? Is there a value of R on the interval from 3 to 6 such that the first derivative is equal to 0? Give a reason for your answer, and if such an R value exists, find that value of R. What theorem do you think is being asked to use here? Hopefully, you recognize that because they're asking for the first derivative equaling 0, and it's within this interval from 3 to 6, they are asking you to see if Rolle's theorem applies. Now, With roles, you have to ask the same questions. Is it continuous? Is it differentiable? And do the values, okay, at the endpoints equal the same thing? Well, we know that this function is only discontinuous at 0 and -3. So that's outside of our interval of 3 to 6. So we can say for part 1, it is continuous on 3 to 6. Okay? We can also say it's differentiable because we do not have a cusp or an absolute value or a piecewise function. So we automatically know it's differentiable on 3 to 6. So then our next question is does f of 3 equal f of 6 or c of 3 equal c of 6? And if you figured this out, these both equal 8,333.333. Therefore, Rolle's theorem is applicable. Okay, Rolle's theorem is applicable. So now that we know it's applicable, we have to find the first derivative and set it equal to 0. All right, so to find the first derivative, okay, we are going to do first get a common denominator in this problem in order to make this an easier problem to find the first derivative of. And to get a common denominator, we would get x plus 3 plus x squared all over x times x plus 3. Go ahead now and find the first derivative. If you found the first derivative, it would be 10,000, and now we're going to have to use the quotient rule. So 1 plus 2x times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. Please now find the value of r. Okay, so let's look at part C now. For the interval 3 to 9, what is the greatest cost for order and transportation? Ooh, that term greatest should symbolize to you a maximum. And this should symbolize the use of the extreme value theorem. Okay, the extreme value theorem. Now remember, the maximum can occur at the endpoints or at the critical points, which you just found in the previous problem of 4.098. If you plug those all into the equation, you get the following. So the answer to this, what is the greatest cost? The greatest cost is $8,611.11 when x equals 9. Okay, I'm going to have you do the entire next problem on your own. For part A, you're being asked to find the value of the first derivative at 2.5. For part B, you're asked to find the average rate of change of the cars sold over the first 12 months. And remember S sub 0, all right, S sub 0 would be your first month, and then S sub 12 would be your last. And then part C is asking you for a possible value of C such that the first derivative is equal to the average rate of change. Good luck, everybody.